3, 2, 1, 0. Hey everyone, welcome to this tutorial. My name is Leonardo Fabian, and today we were going to walk through 5 statistical analysis using a CARS dataset in Excel. We will using hypothesis testing that is basically a way to use data to answer real questions. Like, are car high price in one region actually higher than another, and if we predict cars price based on horsepower, engine size, etc. So the first question is the average price of cars in the west region statistically different for the south region? So basically, to address this question step by step, we first of all filtered the data. We used select west, copy and paste in another row. Also we need to do it with south. Here I have the data, and then we go to data analysis. We will run a two sample assuming equal variances, and then OK, and then we select the data that we want to run, west and south, and then OK. And this right here is basically this one right here. So what does it mean, these numbers? Basically the west average price is $14,031, and the south price is $14,546. The difference is real, but statistically is it, and with the p-value we will to find out. Basically our p-value is 0.76, much higher than 0.05. So what does it mean? That so we don't reject the null hypothesis. Even though the average looks slightly different, the difference is not big enough to consider it a real. So this is not statistically a difference. The question number 2 is, can Howich millage predict car price, and is the result significant? Here we will use a linear regression. These methods find the best straight line and describes the relationship between variables, in this case peak price and peak RPM. To do it here in Excel, we go to data, again data analysis, we run a regression OK, and then we select the input that is the price, and another input that is the peak RPM. So then we OK, and then spread this summary that is here. Basically we're looking for the slope, the R-square, and the correlation. And basically what does it means these numbers? These numbers said that the 0.9 the high millage explains about the 49% of the price variation, and the slope that is negative $9 basically means that for each extra mile per gallon, the price drops by about $890. So this makes sense because fuel efficiency cars tends to be smaller and cheaper, while powerful cars burn more fuel, so it's more expensive. And then here also the p-value that is right here is important because the p-value is below than the 0.05. So what does it mean? That direction is statistically significant. Howich millage is a real predictor of the car price in this model. And then the question number 3, this is two models, and we find out which is better, a predictor of price, horsepower, a peak RPM. For do this, we first of all we need to do a scatter plot. To do a scatter plot, we select horsepower and price, and then we go to insert and a scatter plot. So this is the result. And then for we need to do a correlation for know if the correlation is positive or negative, and to do it this is using the function correl, and then select the data that we want to compare. And finally we need to use a summary regression that we already did it in the another sheet. And what say the correlation? Basically the correlation is a positive strong correlation because it's near to 1. So and the 0. And the r squared, that is 0.65, that means that the horsepower explains the 65% of the price variation, and the slope, that is $163, means that for each extra horsepower that adds about $163 to the price. And to see the real difference or statistical difference, the p-value, that is 0.01, is below than the 0.05. So basically this model is statistically different. And then we compare with the scenario B, that is peak RPM, and to do this is the same steps for the horsepower. And what say the values? Basically the values say that the correlation is a negative strong correlation, so there is no correlation here. It's almost zero, so it's any relationship. Also the R square that is here, the peak RPM explains less than the 1% of the price variation, so this is so poor. And finally the p-value is higher than the 0.05, so this means that the model is not significantly different of the price. Next, in the question number 4, we have, can we predict price using both engine size and horsepower together? This is a multiple linear regression. It's the same idea as before, but now we use two predictors at the same time, horsepower and engine size. To run this we need to do a regression statistics, and it's the same as before. Go to data and then data analysis, and then we select regression, and then select in the input range the engine size and horsepower. Then we lock this spread like this, and then we have this one is basically the summary. So what does it mean, this variation? Basically the R square, that is right here, this is 0.79. So this means that engine size and horsepower together explain 79% of the price variation. It's basically the best model in the whole project. Also the engine size is $122, mean that for each unit of engine size adds $120 to the price, and it's the same for horsepower. For each horsepower extra adds $58. So that's because engine size and horsepower are related. Bigger engines make more power. When both are in the model, they share the credit. Also the p-values, we can observe that is statistically significant because the p-value is below than 0.05. So basically both variances are significant and together explain almost 80% of all of these both variances, and is the relevant most result. And there the number 5 is north and east region have a different shares or high in horsepower. We need to cut off a defined high horsepower. We will use the average horsepower and of the whole dataset, and care about the counts as a high horsepower. So the first step is calculate the average. Then for calculate the average is we need to to select the formula average and then the raw horsepower, and then we need to calculate the total cars per region. After that, we need to calculate the proportions. We need to count the cars above the median region, and after that we need to calculate the proportions, that is divided the total, the cars per the above the cars per region divided in the total, and then we need to run a set test for two proportion. In so in that difference between 30% and 40% and 40-60% is real or just a coincidence. So we need to first the poly proportion, we need to combine it average in both groups, that is this one right here. After that, we need to calculate the standard error, that is this one right here. This means how much the proportion could naturally vary just by chance. And then finally, the C statisticals is how apart the both two proportions are. So is negative 1.48, and finally we need to find out the p-value. Basically the p-value is 0.099, just above 0.05. So we do not reject the null hypothesis, meaning that the east has more high horsepower cars with a 46% versus 30%, but with only 50 cars per group, we don't enough data to get a conclusion. So we need more data to become a significant result. And that's it for this dataset. And here are some YouTube link videos that help me to understand better how to do it, C test and test value, T test value. Also to understand better the topic, test student, also how use it, another ones how to do a linear regression in Excel, also what is hypothesis testing and the null hypothesis and the p-values. So I hope you enjoyed this video, and thank you for your attention.